Hello everyone, welcome to the next tutorial. In this tutorial, I'm going to solve more problems based on basics of network theory. Okay, so let's start with the first problem. Okay, so in the first question, so this question was asked in your GATE 2014. Okay, so in this question, the value of the resistor R is given to be 25 plus I by 2 ohms, where I is the current in amperes. So we need to find the value of the current I, okay? So in this diagram, on applying Ohm's law, we can see that like V is equal to IR. So the value of the voltage is given to be 300 volts. So it means that 300 is equal to I into, on substituting the value of the resistor, it will be 25 plus I by 2, okay? So on further solving it, we are getting I square by 2 plus 25I minus 300 is equal to 0. So it means that I square plus 50I minus 600 is equal to 0. So on solving this quadratic equation, like I square plus 60I minus 10I minus 600 is equal to 0. So on taking I as common, we are getting I plus 60 minus 10, I plus 60. So it means that, so this implies the value of current I is equal to minus 60 amperes and 10 amperes. Okay. Also, we know that R is equal to 25 plus I by 2. So, on substituting the value of I is equal to minus 60 amperes, we are getting 25 minus 60 upon 2, which is equal to minus 5 ohms. Since the value of the resistor is coming out to be negative, it means that this is not an authentic value of your current. Okay. Also, I is equal to, on substituting the value of I equal to 10 amperes in the equation, we are getting R is equal to 25 plus 10 upon 2, which is equal to your 30 ohms. So I is equal to 10 amperes is your correct answer. Okay. So now let's solve the second problem. So this question was asked in GATE 2019. Okay. And in this question also, we need to find the value of the current I which is flowing in the circuit. So we need to find the value of this current I. So let's apply nodal analysis in this figure. So let's say the voltage at this node is your V. So on applying KCL at this node, we can say that like 20 minus V upon 2 is equal to minus 2, because the current flowing in this branch is minus 2 amperes, plus V minus 5I upon 3. Okay. So from the figure, we can clearly see that like 20 minus V upon 2 is equal to I. It means that V will be equal to 20 minus 2I. Let's say this is your first equation. So on substituting the value, we can clearly see that it means that I is equal to minus 2 plus 20 minus 2I minus 5I upon 3. So on further solving it, we are getting 3I is equal to minus 6 plus 20 minus 7I, and 10I is equal to 14. So it means that I will be equal to 1.4 amperes. So the current flowing from this branch is equal to I is equal to 1.4 amperes. So I hope it is clear how we are solving this particular problem. So that's all for today, guys. I will see you in the next tutorial.